All right, matrix multiplication. So very difficult topic today, very important going forward. Okay, so really, really pay attention when you watch this video, okay? So what I like to do, first off, let's talk about how we know to multiply right away, because unfortunately, it's not like addition and subtraction. Remember when we had addition and subtraction, it was like same dimensions, boom, good, right? Okay. You would think with multiplication and dimensions are the same, we should be good to go, and that's just not the case, okay? So really pay attention. To multiply one matrix by another matrix, the number of columns from the first matrix must equal the number of rows from the second matrix, or the, I'll explain what this means in a second, middle numbers should be the same when you write out the dimensions out in order. Remember, order matters. So an example of that would be this, right? Say we have a 2 by 3 times a 3 by 2. So recall, this is rows times columns, rows times columns. And so what I'm looking for is that the columns from the first match the rows from the second. Or these middle numbers are equal. Okay? So these middle numbers are equal. So once you determine, okay, that you've got two matrices that you can perform multiplication, because again, guys, just like with addition and subtraction, sometimes it's not possible with matrices. Okay, that's where matrices have been different from a lot of things we've learned about this year. Because pretty much whenever you want to multiply something or add and subtract something, we've been able to do that. Okay? Vector multiplication, vector addition, subtraction, we just couldn't divide. Okay? So now, what is going to be the dimensions though of our final of the result of multiplying these? Well, to determine that, you take the rows of the first one times the columns of the second. So in this case, our solution matrix would be a 2 by 2. Okay? So here's another example. Okay? If I add a 3 by 1 times a 1 by 4, again, rows times columns, rows times column. What do we have here? Our columns and our rows match. So yes, we can perform our middle numbers, same thing there. So then what is our solution matrix going to be? Well, you just take the rows of the first times the columns of the second. And so we're going to have a 3 by 4, so a really big solution matrix. All right. Any questions on that? So now what would an example, sorry, I know I'm running out of room here, doesn't work. What would be with something like this? It would be a 2 by 2 times a 4 by 1. Do not equal. So this right here would be not possible. Okay? Because columns of first matrix does not match rows of second. Sorry, I know that's a lot to say there. So C means it's column, sorry. So because columns of first matrix does not match rows of second. Okay? So let's look at some examples, right? So really pay attention here. So I don't want you, so Miss Latimer was her term, come up with the notes for this. She does something a little bit different, so don't worry about number one. Let's just really focus on two, okay? So first off, let's make sure we can perform matrix multiplication. So let's look at our dimensions here. So we have a one row, so we have a 1 by 3, and then we have a 3 by 2. Okay? Actually, I should have put that down below, sorry, because I'm going to show you what I'm going to do here. Okay? So we have a 1 by 3 and a 3 by 2. So what does that tell me? Well, can we perform matrix multiplication? We look at our middle numbers here. Those are equal. So yes. So then your solution matrix so now how do we come up with that solution? So here's what I like to do. Okay? I come over here and I draw a one row. Give me some space. 2 columns. I label, and this is where, gosh, I wish I had different colors. Maybe I do hear me about different color pens. Let's see. Oh, yes, I do. Let's go. Sorry. No need to get super excited, but hey, let's do it. So what I do is I take the first matrix here and I just label the rows. So I label that as R1 because we only have one row. I then take the second matrix and not the rows, I just label the columns. So column 1, column 2, and so then I translate that down to here. So then where the columns normally be column 1, column 2, row 1. So what that means is I'm just doing row 1 from the first matrix times column 1 of the second matrix. Okay? So we go in order here. So it would be -2. Jeez, I need more space. No, I don't think I gave myself enough space. So again, by doing that now, it's row 1 times column 1. So where's row 1 from the first matrix? -2, 8, and 4 times column 1 of the second matrix. So I'm going to have -2 times 3. -2 times 3, so -6. And you want to put a plus sign in between. 8 times -1. 8 times -1. So -6 minus 8. And then last but not least, 4 times 5. 4 times 5 plus 20. So again, let's watch how I did that. I did row 1 times column 1, all going in order. -2 is first, 3 is first, right? In each of their, so in the rows, -2 is first, and the column 3 is first. So -2 times 3, -6. 8 times -1, -8. 4 times 5, 20, and then we'll continue that here in a second. Now we move on to row 1, column 2. Row 1, column 2, so same thing in order. -2 times 4, -8. 8 times 2, 16. And then 4 times -6. 4 times -6, -24. So now the hard part's over with. Now we're just going to go ahead And we are going to simplify, and so then our final solution is going to be this. Negative 6 minus 8, that's a negative 14 plus 20. 20 minus 14, that gives you 6. Negative 8 plus 16, that's a positive 8. Negative 24 plus 8 is going to give you a negative 16, and there you go. There's your final answer right there. So again, that's a little tricky. Okay, I'm not going to lie. Okay. So it's a little tricky. Just really, if you got to go back and play that again, play that again. We're going to move on to number 3. So this time, what do we have here? We have a 3 by 3, and we have a 3 by 2. So our middle match, so we can perform multiplication here. So we take the rows of the first, the columns of the second, and we see that we have a 3 times 2 equals our solution. So what I'm going to do immediately then is I'm going to go ahead and I'm going to draw a 3 by 2. So I've got 3 rows, 2 columns. So 3 rows. I'm going to make these boxes a little big. Sorry, you need to have some space for this. Okay, now, what do? I go to the first matrix and I just label the rows. So row 1, row 2, row 3, and then I go to the second matrix. I'm only concerned about the columns. Column 1, column 2. Now we're going to transition that down to our solution matrix, right? So I'm going to have row 1, row 2, row 3, and then column 1, column 2. So what that means then, guys, here, and this starts to get tricky. This first, right here, this first one is row 1 times column 1. Row 2 times column 1. Row 3 times column 1. Row 1 times column 2. Row 2 times column 2. Row 3 times column 2. Okay, so let's go ahead and let's do it. So row 1 times column 1. So in order here, 6 times 7, which is 42. 3 times 6. Remember, I'm doing row 1 times column 1. 3 times 6, 18. And then 0 times 5, so plus 0. Okay? Row 2, column 1. So now I'm only looking at row 2 times column 1 going in order. The 2 is first, the 7 is first. So 2 times 7, 14. 5 times 6, 30. 1 times 5, 5. Okay, so we just went in order there. 2 times 7 because they're the first two. 5 times 6 because they're the second. 1 times 5 because they're the third elements in each row and column there. Now we're looking at row 3. Okay, now we're looking at row 3. So we've got row 3 times column 1. So the first element in row 3 is 9. The first element in column 1 is 7. So 9 times 7, 63. Second element in row 3 times second element in column 1. 8 times 6, 48. And then the third element in row 3 times the first element in column 1. 6 times 5, 30. Okay. All right, now we're moving on to row 1, column 2. So the first element in row 1 times the first element in column 2. So 6 times 4, which is 24. Second element in row 1 times second element in column 2, 3 times 7, which is 21. And then third element in row 1 times third element in column 2, 0 times 0, which is 0. Okay. Row 2 times column 2, Row 2 times column 2. So first element in row 2 is a 2. 2 times 4 is 8. Second element in row 2 times second element in column 2. 5 times 7, 35. And then now the third element in row 2 times the third element in column 2. So 1 times 0, 0. Okay, row 3 now times column 2. So first element in row 3 times first element in column 2. So 9 times 4, 36. Second element in row 3 times second element in column 2. 8 times 7, which is 56. And then now the third element in row 3 times the third element in column 2. 6 times 0, which would just be plus 0. So now the hard part is done. Okay, the hard part is done. Now we just need to combine all these. And some of these I can't think off the top of my head. So our solution then, we don't have to write as big this time because now we're just going to fill it in. So 42 plus 18, 60, 24 plus 21, 45, 14 plus 30, that is 44 plus 5, that's 49. Okay, this bottom one here, I can't think off the top of my head, I'm going to use my calculator. 63 plus 48 plus 30, 141. Okay, and then we've got 8 plus 35 there. That's going to be what? 43. And then 36 plus 56, 92. And there you go. So there's your solution. So that is matrix multiplication there. Okay, that is matrix multiplication there. So what happens if we switch the order of matrices? Okay, well, if you switch the order, okay, how do I want to say it this way? If you switch the order, let's explain this. So like if I did this, right? What is 2 times 3? 6, right? Okay. What is 3 times 2? It's also the same, right? So it stays the same. Okay? Unfortunately, though, with matrices, that is not always true. Say A times B gave us this matrix 1, 2, 3, 4. Okay? That does not mean, though, that B times A also equals. It's not guaranteed. It's not guaranteed. Okay? And the reason is sometimes when you switch, right? So say one, it just has to do with the anatomy of a matrix. But say we did this. So say A equals a 2 by 2, B equals a 2 by 3. So then A times B equals a what? A 2 by 3. It works, right? Because what do we have here? Our two middles work. But then what happens if we switch orders, then we let B go first? Well, then what happens? My columns of the first one is a 3. My rows of the second one is a 2. So that would give me a, would not be possible. So what is happening then is that not only is it not always possible if you switch the order of the matrices, you also are not guaranteed to get the same matrix as if you did not switch the order. That's what that's saying. Okay? So please make sure you watch the video of this section, because if not, you're not going to totally understand. And I'll be honest with you, like, that's a great quiz question to ask. Okay? All right, so let's go down here and let's look at these last two, and let's kind of do what it's asking us to do, right? So let's multiply these two together here first. Okay? So we're going to just switch the order and see what happens here. So we're going to do a 2 by 2. We get a 2 by 2, a 2 by 2. So can we first off perform the matrix multiplication? We can, 100%. And the reason why is because our two middle numbers match. So therefore our solution matrix is also going to be again, you're just taking the rows of the first, columns of the second. There you go, multiply them together. And that's how you get your solution matrix. So for this first part, just so that we have room, I'm going to write it a little bit bigger out. And then the answer will become a little bit smaller, okay? So again, I don't know why I put away my colored pens. I apologize. Give me a second to get those back out. So remember, the first matrix, we just label the rows. So there's row 1, there's row 2. And then on the second matrix, we just label the columns. Column 1, column 2. All right? And so then on our solution matrix, we also just label the same color so we know where to look. So row 1, row 2, column 1, column 2. And so that means then this first line right here is going to be row 1 times column 1. So the first element in row 1 times the first element in column 1, that's a 2 times 6. So we get 12. The second element in row 1 times the second element in column 1, so negative 3 times 1, so minus 3. So we get 12 minus 3. Okay? Now we're looking at row 2, column 1. So the first element in row 2 is a negative 5 times the first element in column 1 is a 6. So negative 5 times 6, that's a negative 30. The second element in row 2 times the second element in column 1 is going to be a 1 times 1, so plus 1. Now we're moving on to row 1 times column 2. Row 1 times column 2. So the first element in row 1 times the first element in column 2, 2 times negative 2 is a negative 4. The second element in row 1 times the second element in column 2 is negative 3 times negative 1. And so we get plus 3. So now we're looking at row 2, column 2. So the first element in row 2 times the first element in column 2, negative 5 times negative 2, positive 10. The second element in row 2 times the second element in column 2. So 1 times negative 1 minus 1. And so what do we get when we multiply these together? Now we're just going to add our lines together. Simplify. So 12 minus 3, that's a 9. Negative 4 plus 3, that is a negative 1. Negative 30 plus 1, that's a negative 29. And then 10 minus 1 is a positive 9. And so that's what we get from multiplying those two matrices. Now let's look what happens here when we switch order. So now we're taking our original second matrices, we're flipping it with the first matrices and multiplying those together and see what we get. So first off, in this case, okay, in this case, we're going to do a 2 by 2 times a 2 by 2 in this case. So in this case, it still does work. Okay, it still works. Okay, it still works. because we have the middle numbers there. Sorry, I'm having brain farts. I apologize, guys. So it still works. So then what is our solution matrix going to be? We take the outside rows times the columns. So then we're going to also have a 2 by 2 solution matrix. So now let's go ahead and let's draw that 2 by 2. We'll draw it a little bit bigger here because we need some space. Okay, and so here we go, right? So we're going to go row 1. Again, label just the rows of the first matrix. So row 1, row 2, because I'm not concerned with the columns from the first matrix. And then just the columns of the second. Okay? Because I'm not concerned with the rows of the second. I'm just concerned with the columns. Okay, so again, row 1, row 2, column 1, column 2, and there we go. Okay, so we've got row 1 times column 1 here. So row 1 times column 1. So the first element in row 1 times the first element in column 1. So 6 times 2, 12. The second element in row 1 times the second element in column 1. So negative 2 times negative 5 plus 10. And see, you can already tell without even starting, they're not going to be the same. It's okay, let's finish that. Just more practice. Row 2 times column 1. So row 2 times column 1. So the first element in row 1. The first element in column 1. So 1 times 2 is 2. The second element, okay, in row 2 times the second element in column 1. And so that's going to be negative 1 times negative 5, which is a positive 5. Now we're moving on to row 1, column 2. Okay, row 1, column 2. And so that's going to be the first element in row 1 times the first element in column 2. So 6 times negative 3, negative 18. The second element in row 1 times the second element in column 1. So column 2. So negative 2 times 1. Negative 2 times 1 is going to give you a negative 2. And last but not least, we're doing row 2, column 2. So row 2, column 2. So we're going to get the first element in row 1 times the first element in column 2. So 1 times a negative 3 is a negative 3. And then we're going second element in row 2, which is a negative 1, times second element in column 2. So negative 1 times 1 is going to give you a negative 1. So now that we've done the hard part, go ahead and just simplify, and here's what we get for our solution. So 12 plus 10, that's 22. 18 minus 2, negative 20. 2 plus 5 is 7. Negative 3 minus 1 is a negative 4. And there you go. So as you notice, like we said, in a lot of cases, 1, they're not always the same. And 2, sometimes you can't even perform the matrix multiplication. In this case, we were able to because they were both square matrices. You always will be able to if you switch order. But if you don't have a square matrices and you switch, sometimes, it doesn't work majority of the time. Okay? Order. All right. That was a long video today, but matrix multiplication is difficult. I'm signing out, and I'll see you guys in class. Thanks.